Here's an interesting question. A block of mass 2 kg with an initial velocity of 2 meters per second undergoes a head-on collision with another object of same mass. We need to find out what is the maximum possible loss of kinetic energy due to collision. Now, there are certain things you should know about all types of collisions. Elastic collision is a collision in which there is no loss of kinetic energy, the objects completely reform to their original shapes. In perfectly inelastic collision, objects do not reform to their original shapes at all, they remain in the state of maximum deformation, and due to which there is maximum potential energy stored in the objects at that state, and therefore there is maximum kinetic energy conversion from to the potential energy. So perfectly inelastic collision is the collision in which there is maximum loss of kinetic energy. So for the first part, when we need to find out maximum possible loss of kinetic energy in the collision, we'll take the case of perfectly inelastic collision. So for perfectly inelastic collision, we know that the two objects after collision stick to each other. This was the initial state. The final state becomes both these 2 kg objects move together with velocity v. Now in all types of collisions, we know that we have one equation of momentum conservation. Because in this collision there was no external force present in the horizontal direction, therefore we apply momentum conservation on the system in horizontal direction. That gives us 2 into 2 is equal to 4v. Therefore we get v is equal to 1 meters per second. Therefore we can now find out the final kinetic energy of the system. The final kinetic energy of the system comes out to be half m plus m into v square, that is equal to 2 joules. The initial kinetic energy of the system was half into 2 into 2 square, that is equal to 4 joule. So maximum loss in kinetic energy that can occur is 2 joules. So this is our final answer for the first part, that is maximum possible loss of kinetic energy. It occurs in the case of perfectly inelastic collision, and that is equal to 2 joules. So now we know the answer for our first part, that is 2 joules. In the second part we have been asked actual loss in kinetic energy is equal to half of above maximum. That is loss in kinetic energy. Actually what has happened is that it is not a perfectly inelastic collision actually. Actually what has happened is that the loss in kinetic energy is 1 joule. So let us redraw the diagram for collision. This was the initial state. In collision questions, you always draw the initial and final state and then write the equations. 2 kg object. Let this go with V1 and let this go with V2. So we can write one equation of momentum conservation which is always with us, that is 2 into 2 is equal to 2V1 plus 2V2. So we get the answer of V1 plus V2 as V1 plus V2 is equal to 2. This is one relation we get in V1 and V2. The second relation which we get in V1 and V2, is through this relation, that the loss in kinetic energy is 1 joule. Let the initial kinetic energy was 4 joule as we know. So the loss in kinetic energy is 1 joule. So final kinetic energy will be equal to 3 joule. So the final kinetic energy of the system comes out to be 3 joule. Therefore half 2 plus 2, half into 2 into V1 square plus half into 2 into V2 square is equal to 3. Therefore we get V1 square plus V2 square is equal to 3. We get this equation. We can make a quadratic and solve for the values of V1 and V2, but that is not a good way to do. The better way is, the fact is that we do not need to find out the values of V1 and V2. We want to find out the coefficient of restitution. This was our diagram. We need to find out the coefficient of restitution. Now we know that the coefficient of restitution is equal to velocity of separation along the line of impact upon velocity of approach along the line of impact. Let me write this: velocity of separation along the line of impact. People generally forget this thing, and in difficult questions they come up doing a mistake. So always remember this thing: if the velocity is not along the line of impact, you have to take the component of velocity along the line of impact upon velocity of approach along the line of impact again. So we are, if we write V, E is equal to velocity of separation. Now velocity of separation is seen as, there is an easy way to find out velocity of separation, that is, what is the relative velocity of front object with respect to the backward object. That is, with what speed relative to the back object is the front object moving ahead. So with respect to this object, this one is moving away, that is separating with a speed of v2 minus v1. Now similarly for velocity of approach, what we see is that with respect to the front object, relative to the front object, with what speed is the backward object coming towards it. That is, with what speed is the back object approaching the front object relative to the front object. That is 2 meters per second, because this object is at rest in this case. So we need to find out this coefficient of restitution. So if we can find out v2 minus v1, we can easily find out coefficient of restitution. So instead of solving the quadratic equations, what we can intelligently do is, we write these two equations: v1 square plus v2 square is equal to 3 and v1 plus v2 is equal to 2. We know that v1 plus v2 whole square plus v2 minus v1 whole square is equal to 2 times v1 square plus v2 square. Using this equation, we can directly find out v2 minus v1 by filling in the values. 4 plus v2 minus v1 whole square is equal to 2 times v1 square plus v2 square, that is 3. Therefore we get v2 minus v1 whole square as 2. Therefore v2 minus v1 is equal to root 2. When we fill in the value here, we get E is equal to root 2 upon 2, that is equal to 1 upon root 2. So this is the final answer for part B, that is the coefficient of restitution. So the fact is that you have to be always aware and take shortcuts whenever there are chances. If you would have done this question by solving the quadratics, it could have been solved, but that would have just become a little bit difficult.